Okay, continuing on, let's talk about selecting holding methods and sequences. Often the greatest challenge is how will the work be held? We just looked at fixtures, a common industrial solution, but remember, if they are planned, then one must also begin another chain of events to get the fixture ready when the job goes to the machine. So standard tooling, in the drive to be creative, don't dismiss the obvious simple solutions of standard chucks, standard collects, vices, drill bolt downs on mills. These are all possible ways that you can be doing that. So here's a key point, the setup time versus tooling cost. When deciding between standard tooling and custom made, consider how many times this job is anticipated to be run. Sometimes a few $100s spent on a custom holding tool returns thousands in quick machine setup and quick part changing compared to using standard tools. Again, evidence of how critical planning can be to a company. So that's also part of the things that we're thinking about for you being an engineer. You're doing the planning and making sure that everything in the factory is working smoothly. So for soft jaws made during the setup, another good solution are soft jaws, usually made by the setup person, both for lathe or mill work. In terms of a trade tip, don't miss the tip of using the part program to make the jaws. It's not a beginner method because it requires editing part program compensation to cut to the other side of the geometry line, along with changing or hiding other program details, but it does work. So continuing on, how else would you hold this ball and clevis to hold the threads without a set of soft jaws? So this is what we want to be thinking about. And so for the figure gives us some thoughts about that. Having a custom bore soft jaws is what we're trying to think about, and this is something that could be made during setup. So for cut sequences, compared to manual machining, operation sequences do change since you have so many options as to how to achieve a given shape. For example, recall the transmission case that had to be mounted on a manual lathe faceplate to bore the bearing hole. Now we want to be thinking of how we would add a circular interpretation. Now it doesn't need to be bored. Employing a CNC, it can be circular milled. The operator can control the bore size to very close tolerances using tool radius offsets much faster than trying to adjust a boring head. So for a trade tip to control bore size, the end mill needs to be assigned its own radius offset in the program, and that should be spelled out in the setup document. So take the challenge. Try to remember it's supposed to be fun. And so that's ultimately what we're thinking about as we're finishing up this module. So for a conclusion, take the challenge as you evaluate your program planning for the value body. Recall that no plan is perfect, nor is it ever quite finished. To prove that point, I did something a bit radical for a textbook. I solved it, then without showing them my solution, Bates in Tacoma, Bob Shoren was the instructor, solved it too. Their solution planning is alongside mine, and it's brilliant. So this is just a quotation from the author of the textbook. Exactly as expected, our solutions couldn't be a lot different, yet they both work. Let's see yours. Work together and try not to look at the two solutions until you are positive your team has the best yet, and I have no doubt many will do great. So we're going to be working as individuals, but this might be something interesting for you to be thinking through and work through that suggested exercises that they're talking about. Okay, that's going to end for this module, and now we're going to get into specifically starting to do some CNC programming.